Okay, good afternoon, everyone. So, oh yeah, before we get started, let me remind you a couple things. Let me remind you assignment number 4 is due today. 11:59 p.m. Also, there was a typo on assignment 4. Tau is like this, supposed to be this an R cycle like this. And then you're supposed to show that sigma tau, sigma inverse is sigma A1, sigma A2, all the way up to sigma A. And then in the assignment, I had sigma AN, which doesn't really make sense. But if you change it to sigma of AR, that is now making sense. Okay. This is a typo. Used to be AN, but it really should be A sub R. Okay. Also, there is going to be the first coursework exam. That will be on this Wednesday. Okay, so and you'll have 12 hours, like it'll be available to hand in for 12 hours. It's not supposed to take the entire 12 hours. Should take about, I have a bunch of chats. Oh, sorry. Yep. Good afternoon, everyone. Okay. For the exam, should not take 12 hours. Oh, this is a good question. What time will it be released? So I think that my plan is to have it available. Oh, I already said 10 a.m. If it's okay with you guys, I would like to change it to be from 12 noon to 12 midnight. Yeah, if that's okay. My thinking is that a person who gets home from work at around 6 or something, they'll still have enough time. Okay, so my thinking for this exam is like an hour to do the questions and then another hour to even write them up. But that is being, I think that is an overestimate, I hope. Okay. So 12 noon to 12 midnight. Oh, how many questions? 4 questions. And they cover the topics of assignments 1, 2, and 3. Okay. So what I would suggest is make sure you're familiar with the concepts in those assignments so that you're not having to chase down all the definitions during the exam. You can check out the solutions of those assignments. Also, try to see where you went wrong. Commutators of a group. Oh, so sorry, there's a question. I just want to be sure I'm getting it. Are you asking if the commutator subgroup is equal to the center of a group? Okay, no. Sometimes, yes. Just as a quick example, so we've seen a couple examples where they're the same. They can be very different. Okay, first let me answer this question about the commutator subgroup, then I'll circle back and say everything about the first coursework again, just to be safe. Okay, so just to answer the question about the commutator versus center, you notice that they can be the same sometimes. Like for the quaternions, we have plus or minus 1, plus or minus I, plus or minus J, plus or minus K. That's one way to think about the quaternions. The center of the quaternions are just plus or minus 1, and the commutator subgroup is also plus or minus 1. We also saw that this group of upper triangular matrices with 1s on the diagonal, that had the same center as the commutator subgroup. I think I call this group H, which is like the things like 1, A, B, C. The center of H was equal to the commutator subgroup. Okay, and another example is that D4, the center of D4 was just the identity in A squared, and the commutator subgroup of D4 is also that. Okay, and in fact, you can see like the center of the quaternions and the commutator subgroup of the quaternions in D4 are like both isomorphic, but okay. But it's often not the case that these things match up. For example, we look at D5. D5, the commutator subgroup of D5 is just a subgroup generated by A. Because A squared is a commutator, as you saw, and then that generates a subgroup. So you get D5 prime. Whereas the center of D5 is trivial. Another example, an abelian group. If A is any abelian group, then the commutator subgroup of an abelian group is trivial, but the center of an abelian group is the entire group. Okay, so many examples can be found where the center is not the same as the commutator subgroup. I'm sorry if the questions kind of were misleading, maybe to make you think that these two things are different. Another example you could work out that the center of like S5 versus the commutator subgroup of S5, those are going to be different too. Mostly they're not different rather than being the same. Okay. Now let me just go over the details of the first coursework. Yes, that is a good question though, about the commutator and the center. Thank you. Okay, but let me now circle back to the coursework exam. Okay, it's on this Wednesday. Okay, I'll have it available between 12 noon and 12 midnight. It's going to be 4 short answer questions. Okay. The topics are going to be the first 3 assignments, like what the first 3 assignments cover. Okay. Assignments 1, 2, 3. Okay. So what you should do, well, you might know how you study best, but what I would suggest is that you review kind of all the relevant concepts in these assignments. Okay. You look at the solutions to the assignments, see if they're making sense or not. Okay. Also you could try some of the questions on the assignments that weren't to be handed in. You know, if you do all of that, maybe you've done all of that already. I guess there's always more studying you could do. If you've done all of those questions, I could probably come up with some more questions for you to do if you want. Okay, and then as far as I was also saying that I would expect, like, my plan is to make the exam take about, like, it should be able to be done in about an hour, and then leave some time. So that's just like figuring out all the questions, and then leave some time for you to, like, I don't know, it depends on the person, but leave yourself some time in addition to that to actually write down your answers to the questions, scan them, upload them, leave yourself some time to, in case the power goes out or whatever happens. I know lots of things can get in the way. So, but in terms of just figuring out what's going on with the questions and figuring them all out, I would call it an hour, meaning that if we were having a regular class, this would be an hour-long exam. Okay. Yes, you can submit. I mean, yeah, technically you could submit at 12:30 in the afternoon or 11:59. Okay. Plagiarism form. Let me say, if I want you to, I have yet to decide, but if I want you to submit a plagiarism form, I will put a plagiarism form in the exam thingy for you to upload. If you know what I mean, like, the link for the exam will contain a plagiarism form if that's what I want. Okay. Yeah. Okay. All good questions. So any other info? Is there anything outstanding for the first coursework you want to know? Okay. So let's see. The last thing we did was we proved all the 3 C-lob theorems. And then we applied the C-lob theorems to look at the structure of a group of order 60. Okay. And so as a corollary, we proved that the alternating group on 5 entries is a simple group. Okay. So let me remind you, and try and tie some of that stuff together. Okay. So on Friday, right? We proved that A5, that is the permutations on 5 things, on 5 symbols, which are even. So the sign of sigma is 1. In other words, sigma is an even permutation. All the even permutations, put them all together, you get A5. So notice that the number of elements of the number of elements of the alternating group is 60. And we proved that A5 is a simple group. Among other things, okay. That means if H is a normal subgroup in A5, then H is trivial or A5. That's what being a simple group is. Your only normal subgroup is the trivial subgroup or the entire group. If you, and I guess a related fact is A3 and A4 are not simple, but AN is simple for not only n equals 5, but for all n greater than or equal to 5. Okay. We can do, I want to tell you about another class of simple groups. Just a simple one, a simple class of simple groups. Okay. So let A be an abelian group then A is simple if and only if A is cyclic of prime order. Okay, that gives you, so now you have a bunch of simple groups. You have cyclic group with 2 elements, cyclic group with 3 elements, cyclic group with 5 elements, cyclic group with 7 elements, and so on. Okay, these are all simple groups. Some simple groups. And then you also have A5, A6, and on like that. And then you have other things, lots and lots of other simple groups. Okay. Okay, so let's try and work out our proposition. So proof. Okay, let's suppose we have an abelian simple group. Oh, I guess I should say A is this not trivial, and also, yeah, that's good. So let A be a non-trivial abelian simple group. Okay, let X be an A. And since A is non-trivial, we can choose X to not be the identity. Okay, and now take H to be the subgroup generated by X. Now H is a subgroup of A, and A is abelian, so all like in an abelian group, all the subgroups are normal. So H is normal in A. That's because A is abelian. Okay. So H is normal in A. A is a simple group, so that means that H has to be either trivial or the entire group. So H is trivial or A. It's not trivial because X is not trivial. Okay, so it must be that H equals A. There, that proves that A is cyclic because now A is generated by X. Now, let P divide the order of A. So it'll be some prime. And let H prime be the cyclic subgroup generated by X to the P. Okay. Now H prime has less elements than A does. Because just as an aside, why is that? Well, let's just do it on the side here. If you write n to be the order of A, since P divides n, we have n equals P times M. And now x to the P to the M is the identity. So H prime has M elements, which is less than n elements. Okay, so H prime is not equal to A. Now H prime is a normal subgroup of A, so it's either equal to A or trivial. So H prime is equal actually trivial. And that just means that x to the P equals the identity. Okay, now A is a cyclic group generated by X, and x to the P is the identity. That means A is a cyclic group with P elements. So the elements of A are like this, and now you have x to the P minus 1, and you can stop there because x to the P is the identity. Okay, and that proves like one direction. That proves if you have a simple abelian group, it is cyclic of prime order. Now, if you have a group that is cyclic of prime order, you can prove it's simple. Well, because the order, right? So just now, suppose that A is cyclic generated by X, and the order of A is a prime number. Then if H is a subgroup of A, either by Lagrange's theorem, either the order of H is a divisor of P. So order of H is either 1 or P. If the order of H is 1, it's a trivial subgroup. If the order of H is P, that means it's the entire group, proving that these groups only have trivial subgroups or the entire group as its subgroup. So this would say that H is trivial. This would say that H equals A, proving that A is simple. Okay. Okay. As an example, well, let's go back to our group of order 15. We proved using the Seeloff theorems that a group of order 15 was any group of order 15 must be cyclic. That's a better way to say it. Okay. And we did that like using Seeloff theorems, like some arithmetic stuff. Okay. Okay, so let's see why. Let's try and write down the subgroups of this group of order 15. So let's consider this group of order 15, the cyclic group with 15 elements. In other words, this is the group that's generated by X, satisfying just the one rule that X to the 15th is the identity. So contained inside, you have all the subgroups of this group are, well, you have the subgroup generated by X cubed. You have the subgroup generated by X to the 5th. And of course, you have also like the subgroup generated by E and the subgroup generated by X. This is C15. This is trivial. And these are two proper non-trivial subgroups. Okay. And so if you look at it, so these numbers are just coming from the divisors of 15. You have e x cubed, x to the 6th, x to the 9th, x to the 12th in this group, and then here you have e x to the 5th and x to the 10th. Right. Okay, so this would not be simple. It has these two subgroups. Any subgroup of an abelian group is normal, so it has two like proper non-trivial normal subgroups. Okay, and then what we want to look at, what our plan is now, is that sometimes a group can be built up from its subgroups, and that is the case for this group and these two subgroups. Okay. Okay. Wait. So what happens? Consider the group C3 cross C5. Well, of course, you know that we can take the Cartesian product of two sets, and I haven't really defined how you get a group from that, but if we can, so this will be a group with 15 elements. We know that any group with 15 elements is cyclic. So actually, we have like an isomorphism between, so we can write the cyclic group with 15 elements as kind of a product of two smaller groups. Okay. And in fact, kind of, there's like some arithmetic reason for that, but what we want to do now is we want to look at groups that you get by doing like direct products like that. Or G and H are groups, just a little bit. Okay, so actually now let's just take like just like a 3-minute break. And we'll just talk a little bit about this stuff. Okay, so I'll see you guys in 3 minutes. Okay.